Hello, my name is Blaškić, and I was uh, I was using C++ programming language in my compiling construction project. So far, I managed to successfully do steps from step one, like the range of steps, which goes from step 1 to step 48. I believe I got stuck on the step where I have to have my compiler produce .asm file, or like assembly language code, which is actually gonna be ran on my machine. I found a solution which is not going to work for all of my codes that I'll be generating. It will work for representing it this way and for just showing one code at a time, but I'm still working on figuring out how to do how to test more programs at a time on my machine. So I will start by showing the example of my my code being run, and of my compiler working, and just showing that the tools the things that I implemented actually work, and that my compiler is actually doing the job that it had to do in the first 48 steps, I guess. So first time when I was trying to record this video, I was waiting for my program to be run, and it was a bit slow, so now I already ran it, and now I'm just gonna go through each phase one by one and describe what happened there, was the change in the code state, and how did we get there. After we go over my work, after I show off the result, I'm gonna go over some interesting, some hard, and some stuff that I'm proud about in my work so far. We're gonna go through the images that are the screenshots of my code in C++. So to start off, so once we ran the code, first thing that was printed out was program version in R0 language with the appropriate result for it. This is like a bit tricky code, let's say, because it has let inside, and then it has let inside a let, and they have the same variable names, so it creates a bit of potential. It creates like a danger of potential problem, let's say. Okay, so once we see that runs well, we go to the next step, where next thing printed out is program execution in R0 language with unique variable names. We see here that now, like, first let assigns 5 to x, but next let assigns 6 to x, and this x has to take the x from the second let, but let outside of the second let has to take the value from the first let that the first let assigned to it. So that's why we use unique variable names. So this is more clear when one look at it, kinda, for some other reasons as well, but not important right now. So that's what happened in unique 5 pass that we used in order to change this initial R0 language code to look something like this. In between these two steps, we had optimization step, where we created we are optimizing the R0 language code To be clear, this is actually R1 language in our class, but I left it as a R0 language, the same name. So whenever I say R0, I mean R1. So in between these two steps, as I said, there's an optimizer, and I didn't run it here, but it's commented out in my source code area. So if you want to check it, you can just delete the comments and run the code. It's gonna there's a way to do that, and then go to the header file and like remove from the comment my tester, my function that is called rand p, and then there can be a numerous of programs created on that way, and they're gonna show that my optimizer is working well for unlimited number of programs. Okay, moving on. So following step is program execution in R0 language with unique variable names that we know already, and simplified version for compilation. So this is resolve complex pass, which creates again R0 language, but in a specific way that is readier for compilation to C0 language. After that, we do compilation to C0 language, and we see this following code. This return value is 11 for following return statement line is a product of this return statement. It's above because that's the way I implemented the code. We firstly ran it, and then we have shown the memory state and how the code actually looks like. After that, we have program execution in the X0 language, which looks like following. It has some stuff that we're gonna change in near future, but this is how it looks like. It uses the variables. We're not gonna use the variables anymore in a second. And this is a variable state, and the result is still 11. That's important. Blah blah blah. So far, so on. This is the register state, variable state. Obviously, I've said that already. And then the stack was empty, so it wasn't worth printing it out. And then now we have program execution in X0 language. It is not using variables. It's rather using too much memory, let's say. So this is how we go about it. And then we again have the result 11. We don't use the variables, so they're all just initialized to 0 and never used. Shouldn't be there at all, actually. Think about it, but never mind. We only use one register, kinda. It's RAX for the return value. We use the RSP and RBP, but since we used it and unused it, kinda, it is not shown here. We cannot see here that it was used. So as we can see on stack pointer, on the stack that initially, like the stack portion that we used is actually shown here. This entire thing we actually used. We pushed RBP here in the beginning of the code to save its value. It was 0. Then we pushed let's see here, we pushed 5 on RB pointer on RBP plus 4, offset 4, and then RBP took the value of RSP after it was put on the stack, and it was pointing to 1, the location with offset 1, which is here, and then plus 4, plus 1, 2, 3, 4 is this location where we put 5, and then as we can see in the code, we put 6 after that and 6 after that, and so far so on. So that is working fine. And then the last step that I successfully did, let's say, I did the pass, which creates the X0 language code with only one memory reference per instruction. This is something that just helped me out when doing this stuff. But if we go below it, we can see this is actually a step 48 if I'm not sure. But yeah, I think with this type of setup of the code with begin and end label, and then we have a body, and we can see that there's only one time per instruction. There's only one time that we use base point that we use memory, which is this base pointer with the offset. Okay, cool. So now once we went over that, I want